Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for November 22nd of 2024 is titled the Medusa Nebula. So what do we see here? Well, as you might expect, we see the Medusa Nebula. But what is that? Well, it is an example of a planetary nebula, also known as Abell 21. And a planetary nebula is what happens at the end of the life of a star like our own sun. And in fact, many stars, all stars smaller than our sun, and many stars even larger than our sun, will eventually become a planetary nebula at the end of their lives. Now, what happens at the end of the life of a star is that the core, when it runs out of hydrogen to fuse, becomes a dense ball of helium, which will then collapse down and condense down smaller, and the outer layers of the star will begin to expand. Now this goes on a couple of times because then helium will start to become an energy source. But when that is used up for something like our sun, there are no further energy sources. So the core continues to contract. The outer layers continue to expand until they are no longer held by the white dwarf star forming at the center and are expelled out into space. And that is what gives us the short-lived planetary nebula phase of a star. So again, many stars will go through this, but we don't see lots of planetary nebulae because it's a very short time. It might only last a few tens of thousands of years. Now, while that sounds like a long time to us, for a star like our sun, which could live 10 billion years, it is only a blink of time. It's very short time by comparison. And as those outer layers expand outward, they are then excited by the energy of that white dwarf star. Now the white dwarf is a compact star compressed as close as possible as atoms can be. And in fact, they're to the point where their electrons start to repel each other and prevent the star from then collapsing any further. And that at the center is extremely hot, gives off a lot of ultraviolet light, which then energizes the nebula around it and causes it to glow. So over time, the planetary nebula will slowly fade. And that's for two reasons. First of all, the white dwarf has no further energy source. It will cool off and not give off enough ultraviolet energy to illuminate the gases. Also, the gases are continuing to expand out into space, and eventually they expand farther and farther away and no longer start to glow. So the combination of those two will eventually lead to the end of the planetary nebula, although the material continues to expand outward into space, becoming seed material for future generations of stars. The white dwarf itself will pretty much remain there, just cooling off, and nothing else will happen to it. And it will remain like that. The only exception would be if that white dwarf happened to be in a binary system of stars. So if it had a close companion, then something else could possibly happen. But at this point, for a single star, the planetary nebula is the end, and leaving behind just that white dwarf. So that was our picture of the day for November 22nd of 2024. It was titled the Medusa Nebula. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.